Hello, my name is Marcus Kittikit. This is Assignment 3 for Comp 3122 Applied Data Science at George Brown College. And the overall goal of this assignment is that we're given a house price prediction competition on Kaggle. So the overall goal for this assignment is to join the competition on Kaggle, make a submission data file by uploading CSV file, right? And get a score below 0.3, right? Right here. This is the house price. This is the house price competition on Kaggle, right? Yeah. Let me say so myself. And based on this document right here, to get the full grade, this can be done by following week 9 regression lab. And I did that. That's what I did. So for now, what I'm going to do is that I'm going to execute each code block cell while also explaining what it does. So what it's doing, right? So I'm going to import NumPy, pandas, matplotlib, and seaborn. I don't use seaborn, right? NumPy for logarithm for log price and square root values on the graph, pandas to load the data set, right? And matplotlib to visualize the data on a plot, right? So right now I'm going to load the data set from the CSV from the competition, right? I'm going to define some variables for ID. I'm going to do the type of data set. What's the type of data set? It's pandas core frame.data frame. And I'm going to print out the first 10 rows of the data set. So there's 81 columns. It has an ID row and 80 features, right? So for the data pre-processing, I'm going to drop the ID column because it's not needed with training and testing my linear regression model, right? So I'm also going to check the type of feature, what are the type of feature columns? And the 3 types are int64, object, and float64. And for this linear regression model, for handing missing data, I'm going to list all columns with only numeric values, right? Why is that? Because I will use these columns, numeric values, as potential explanatory variables for sale price, right? So I'm going to execute this, and these are the only numeric columns. Sale price is one of them. So, and I'm going to put it in a variable called numeric calls, right? And put in a for loop. I'm going to discard several rows with missing values in the numeric columns. I'm going to get the first 10 rows again. As you can see, no ID. And yeah. And to see the number of, also going to see the number of rows and columns. So there's 80 columns and there's 1,121 rows. Now it's time to plot the visual data. It's time to plot the data. And I'm going to plot the sale price in a histogram for house price distribution. And according to this histogram, the sale price goes exponentially up and then exponentially down. So what does that mean? It means the house price distribution between 100,000 and 300,000, maybe 400,000 also, is like between 100,000 and 200,000, the house distribution is way up, at least way above 80 in density, right? And then later on, 300,000, 400,000, right? There's less houses at that sale price, and there's a few outliers with some, at least two, being above 700,000. That's a very expensive house. So I'm also going to plot the histograms for all numeric values to see numeric distribution, right? These are all numeric values for numeric distribution, right? And I'm going to choose one of these features for as my for my for my model, right? I think I'm going, and for that, I'm going to choose a feature that is similar to sale price, right? So I want to scroll up, right? This one's similar. Actually, it goes up, down, up. No, and which feature is the most similar? GR Live area, right? Let's check for more. This one's similar. This one's similar. This one's, yeah, yeah. So so there's three features I can choose from: first floor, second floor, right, and GR Live area. I'm gonna choose GR Live area because there's because of the sale price, because of the house distribution between like 100,000 and 200,000. I think this one for GR Live area, the numeric distribution between this and sale price is very similar. This one, they are also similar, but I think they're missing a few potential outliers for 400,000, 4,000, 5,000. This one has it, right? Yeah, the most similar. So I'm choosing GR Live area feature for the model, for linear regression model, right? And so after choosing the feature, I'm going to compute the average. All right, I'm gonna find the number of houses with sale price greater than 200,000. 247 houses, right? I'm gonna find how many houses are there in the MSC zoning category. So what's the MSC zoning category? The MSC zoning category is how you call it? It what identifies the general zoning classification of the sale, right? So what's the general zoning classification of sale price or sale? RL is 874, RF is 175, FB 54, RH 10, right? Right. Now this is something, right, for advanced regression techniques, right? So I'm gonna leave it at that, right? This could be useful if you want to get a lower score, like if we're like if we're trying to get like the highest score on the leaderboard, right? The lowest score on the leaderboard, but we're not doing that. So here I wanted to describe, right? These are all the numeric values, right? And I'm going to find the most expensive house. The most expensive house is 75,000. The least expensive house is 35,000, right? And you can be so yeah. Now it's time to train my model, right? So I'm going to use linear fit using one feature versus sale price. And that one feature is GR living area, right? So I'm going to call X and Y. We're going to trade test split the data set, right? So the test size is going to be 0.2, so at least 20 data sets, right? And I'm going to put it in a scatter plot right here. And I want to print any null values? No. Now I'm going to find the line that best fit. And we're going to visualize this on a scatter plot. And as you can see, the line goes through here. But as it go, like the first between 1,000 and 3,000, it gets all the it goes through all the values, right? The predicted values. But also, as we go further along, there's a very extreme outliers at the bottom right corner, right? So I'm going to remove these extreme outliers and plot the data again. Okay, so there's still some outliers here and there, but this is why I'm going to log the price and square root the living area, right? Why am I log pricing and square rooting the values? Well, because of this hint, right? Working with the features and the target price as it should be is fine, but will not result in high accuracy. So in order to get a higher accurate prediction with the linear regression model, I'm going to have to try apply log price and square root living area. Sorry. So yeah. And for this one, and that's what I did. I'm going to log price and square root the living area. I'm going to do the same process all over again. And you can see we got a different I got a different graph, a different scatter plot. It's more arranged now, and there's only a few outliers here and there. But yeah, it's not too far off. So yeah, this is the line of best fit. And using AB to predict the house price with a house of 40 square feet, right? 12.12, and predict the house price for a sample house in the test set, 12.3. Not too far off, right? Now I'm going to plot the fitted line, which is the model, and I'm going to show the x test and y test and y pair on the same plot. So yeah, this is the scatter plot using plt.matplotlib, right? And as you can see from the line of best fit, there's the test data and the train data. There's the train data, right? So it's not too far off, right? This area right here is going to be the most accurate here in terms of predicting 20, 30, 40, right? So, and now that our model captures most of it, I'm going to compute the error between predicted value and actual value. So import error metrics, mean squared error, the absolute error, and I'm going to print out the errors. So what does this mean? So if my error, if my mean squared error is 0.07, that means that my model is not too far off from the actual value. The error between, so that means my model is accurate enough, right? And what's the mean absolute percentage error? At 1.7273% absolute percentage error. So is it going to be entirely accurate? Is my model going to be like going to predict every house price? No, but it's going to be at least it's not going to be entirely accurate, right? But at least my linear regression model predicts some, if not most, housing prices in this competition, right? And now I'm going to transform the test data using the same transformation as the training data, and I'm going to predict using the model from AB from Polyfit, right? I'm going to check the number of rows, right? 1459 by 1459. Make sure there's no missing IDs, right? And now I'm going to set up submission. So panda.dataframe, test ID, and sale price, right? So according to the sample submission, this is the same submission, right? And I uploaded this, and now what is the house price? What did I get for house price? 0.29208. What's my score on the leaderboard? 1447, right? Not too bad. Not too bad. So yeah, not too bad. It's not too bad for first try. So yeah. So yeah. And yeah, that's it. I achieved the goal of reaching a score below 0.3. And yeah, that's it. Thank you for watching and have a good day.